In this video, we're going to introduce two new ideas, and these are going to be really brief, but then we're going to use them in future videos. So the first is the idea of conductivity. And conductivity is defined this way, where we have the number density of our electrons times the electron charge squared times tau, which remember that was the average time between collisions in our material. So that depends on what type of material it is. And then we have the mass of the electron. Now you might say, where on earth is this coming from? Why on earth do I want to do that? Well, before we had our current density, remember J was current density, equaled this thing, which we said was actually a property of the wire, times our electric field. So what we've done is we've simplified all that stuff down to sigma. And sigma is the conductivity of a material. Again, the idea being that this is either a property of the material or of the electrons themselves. So now we get to say this nice and simple equation that our current density, remember that this is not I, this isn't just current, this is current density, which is just I divided by your cross-sectional area, is equal to something that depends on the material times your electric field. So that's nice and simple. We see that the material controls the relationship between current density and electric field. That's all. And so there will be times that this depends on things like temperature, but in this intro class, we don't usually consider that. Now there is a second quantity that actually we're going to use a little more often, which is resistivity, which is simply the inverse of conductivity. Note that this letter here is the Greek letter rho. It is not P. So this is Greek letter rho, which also gets used for density. I'm sorry. This is absolutely true that we might be talking about the density of the material and the resistivity of a material, but not normally. You be careful with your notation, maybe put subscripts on them or something. I'm sorry, that's the symbol we use. So what's important about resistivity is that it is the property of a material. Again, if you've studied some physics before, you might know about the concept of resistance. We are not talking about resistance right now. We're talking about resistivity, which is again a property of the material like density. So it is overall, you would say the resistivity of gold is always the same. It doesn't matter if it's a small chunk of gold or a large chunk of gold. It's just 1 over the conductivity. So obviously we don't need both of these. One is just related to the other in this very simple way. Conductivity makes a little more sense when we think about current and how we did that microscopic derivation, but resistivity is going to make more sense when we go forward and talk about circuits. So this is kind of where we're jumping from the microscopic view to the macroscopic view. So resistivity does depend on temperature and impurities, so does conductivity, but we normally don't worry about that in this class. You might see a problem or two talking about how this depends on temperature, but we don't normally deal with that. So really quick to show you, let's look at some different materials and note that we're showing both the resistivity and the conductivity. Their units are just the inverse of one another. And so a number that is big in conductivity means it is good at letting electrons move. So our good conductors are metals, aluminum, copper, gold, iron. And if you notice, they have big conductivity, so they really let electrons move. Nichrome is a special type of wire, so you're going to see that come up in problems a lot. That's for heating elements. And then carbon is not a good conductor, so that's kind of included by comparison. Notice that this is orders of magnitude different. So the conductivity is a big number if it's good at letting electrons move around. The resistivity is then a really small number. Notice that this is 10 to the negative 8. So you get closer to 1 for each of these as it becomes a less good conductor, which means it's more resistive. So these are, again, our two properties we'll talk about a little bit later, but they are obviously just related to one another.